Okay, so we're to calculate the volume of the solid generated by revolving the region between x plus y equals 3 and x equals 4 minus the quantity of y minus 1 squared, and we're going to revolve that about the x-axis. Very first thing you should notice is that the first equation is a line. In standard form, we're used to seeing it as y equals negative x plus 3. So the slope is negative 1, the y-intercept is 3, and we can actually get the x-intercept as well by plugging in y equals 0, and we'll get 3 for that as well. Alright, good. The trouble comes in the second equation, x equals 4 minus the quantity y minus 1 squared. That's our standard equation that we're used to seeing. We notice that one of the variables is squared, so it's a parabola, when the other one isn't. And but it's not our normal y equals x squared. It's not x that's squared, it's y that's squared. And so this is a parabola that has been turned on its side. Let's take a look at the intercepts. What happens when x is equal to 0? If x is 0, then we have 0 is 4 minus the quantity y minus 1 squared, or the quantity y minus 1 squared is 4. Don't forget to take this, when you go to take the square root, don't forget the plus or minus. So on the one hand, y minus 1 is 2, but on the other hand, y minus 1 could also be a negative 2. And so we get that two y-intercepts. Y is 3 and y is negative 1. So 0, 3 and 0, negative 1 are the y-intercepts. And we can also get the x-intercept if you like. When y is 0, we're going to have x is 4 minus the quantity of negative 1 squared. Negative 1 squared is a 1. 4 minus 1 is a 3. And so x is equal to 3. So we have 3, 0 is the x-intercept for the parabola. Notice that they both have 3, 0 and 0, 3 as intercepts, and that's going to help us out a lot. Let's take a look at the graph. The line 3, 0, 0, 3. Connect those dots. Now when it comes to parabola, we have the same points. We have another point as well, though. To really help us get a good drawing, it would help if we can find the vertex of the parabola. Let's take a look at, normally, right, we have y is in the standard form, a times the quantity x minus h squared plus k, and the vertex is hk. But we don't have a standard y equals parabola, we have an x equals parabola. And so what we're going to do is just, in order not to switch around the h and the k, leave h as the x coordinate of the vertex and k as the y coordinate of the vertex. Then we have to, in the equation, switch the k and the h. Remember, our equation is 4 minus the quantity of y minus 1 squared plus, so we're going to rewrite it then as negative the quantity y minus 1 squared plus 4. So you can see that our vertex is going to be 4, sorry, yeah, that's right, 4, negative 1. No, 4, positive 1, I'm sorry. 4, 1, yeah, 4, 1. So that's our, oops, that's our vertex, 4, 1. Sorry. Alright, so we have a parabola that has a vertex of 4, 1. Put an extra point in there. And there we go, we're going to connect these, have our parabola. Great. So our region is in between here, and we're going to rotate this region around the x-axis. Let me just color this in. This is our region. I'm going to rotate around the x-axis. So let me just denote that by the following marks. Okay, good. And so we have a choice. We recognize that there's a gap between our region and the axis of rotation. So we have a choice between washer and shell. But we're going to find out that washer is a bit more difficult than shells in this particular problem. And so we're going to do shells. Remember, when you do shells, well, for both methods, you have to start with a typical rectangle. The typical rectangle that we draw with shells is parallel to the axis of rotation. And so here is a typical rectangle that is parallel to the axis of rotation. First off, notice that that rectangle is horizontal. The fact that the rectangle is horizontal actually dictates to you what variable you're going to be integrating in terms of. When your typical rectangle is horizontal, you'll be integrating in terms of y. When typical rectangle is vertical, you'll be integrating in terms of x. And so we have this. This guy is going to move from a low point when y is 0 to a high point when y is 3. So those become our limits of integration. Now we have to find the radius and the height. Remember, with shells, their formula is 2 pi, the integral from a to b, the radius times the height, in this case dy. So let's go find the radius. How do you find the radius? You draw a line that goes from your axis of rotation up to your rectangle. That distance there is the radius. This is going to change depending on where the it's going to change depending on where, we'll just call it R, the position of the rectangle is. The height then is this sideways distance here, h. Okay, great. Now, when your distance is tied to the x-axis like that, then the vertical distance off the x-axis is y. Vertical distance off the x-axis is y. And since our integral is in terms of y, then we can just leave it like that, and that will be our radius, y. The height is a horizontal distance, and we have to recognize that the distance to the line and the distance to the parabola, if we were to subtract these, we would get the distance for the height of the rectangle. But when you're talking about the horizontal distance off the y-axis, that's an x equals distance. And so, let's do it here. So we have, for the parabola, we have x equals 4 minus the quantity y minus 1 squared. For the line, we have x equals, if we solve that for x, we get negative y plus 3. It's the subtraction of these that give us the height. And so we'll just represent it here as 4 minus the quantity y minus 1 squared, and take away the quantity of y, negative y plus 3. Okay, and let's put it all together, and then we will at least have our formula for volume. 2 pi, the integral from 0 to 3, y times the quantity of 4 minus y minus 1 squared, and then minus negative y plus 3. And next time we will finish this